Hi everyone, I am your friend Shadab Imam and we are continuing our lecture series on operations research. So if you are new to the channel, please subscribe the channel and don't forget to hit the bell icon. So in the previous lecture, we have discussed how degeneracy occurs in a simplex algorithm, and we have also seen that degeneracy can occur at any stage of the problem, that is initial stage as well as at the subsequent iterations. And if you have not watched that video, I request you to please go and watch the previous video so that you will have a better understanding of what is happening now. And today I bring to you a very important problem which will clear all your doubts regarding the degeneracy in simplex algorithm. So let us start with the problem. Our problem says maximization z is equals to 12x1 plus 15x2 plus 14x3 subject to constraints minus x1 plus x2 less than equal to 0, minus x2 plus 2x3 less than equal to 0, x1 plus x2 plus x3 less than equal to 100, and x1, x2, x3 greater than equal to 0. Now in order to solve the problem, we need to convert this into standard form first. So to convert it into standard form, we need to make sure that the right hand side values of the constraint are non-negative. Here we can see that 0, 0 and 100, these are the values, these are non-negative values. That means these are already satisfying our prerequisite conditions, and now we are converting it into equality, inequalities into equalities. So I am writing here again, maximize z is equals to 12x1 plus 15x2 plus 14x3 subject to constraints minus x1 plus x2 is equals to 0. Similarly, this will be minus x1, so I can write 0x1 minus x2 plus 2x3 plus s2. This will be plus s1, or I should say plus 0x3 plus s1. Similarly here plus s2 equal to 0, and x1 plus x2 plus x3 plus s3 is equals to 0, and x1 comma x2 comma x3 comma s1 comma s2 comma s3 greater than equal to 0. Now as we have seen that in each of the three constraints there is less than equal to sign, that means we need to add a slack variable. That's why I have directly written here it is minus x1 plus x2. For there is no value of x3, so I have written 0 x3 plus s1 equal to 0. Similarly in the second constraint also I have written 0 x1 as x1 is not mentioned, and this s2 is the slack variable. Similarly in equation 3, s3 is our slack variable, and we need to make sure that x1, x2, x3 and s1, s2, s3 should be greater than equal to 0. Now let us start solving. To solve this problem, we need to make initial basic feasible solution first and see if s1, s2, s3 are eligible to enter the basis column. To verify that, we will put x1, x2, x3 as 0 and see what s1, s2, s3 are coming as. So as we can see that if I put x1, x2, x3 equal to 0, I'll get s1 equal to 0, I'll get s2 equal to 0, I'll get s3 equal to, sorry, it is 100. This is mistake, this is 100, okay, this is 100, s3 is coming as 100. So all these are non-negative, that means they are eligible to enter the basis column. So this is s1, this is s2, this is s3, and these are objective function coefficient x1, x2, x3, s1, s2, s3, and the objective function coefficient we also need to write here, plus 0 s1 plus 0 s2 plus 0 s3. so that it will not affect our objective function, and these coefficients will be written here: 12x1 plus 15x2 plus 14x3 plus 0x1 plus 0s2 plus 0s3. Now we are writing the constraint equation, which is minus 1 1 0 1 0 0 equal to 0. Second constraint 0 minus 1 2 0 1 0 equal to 0. Third constraint 1 1 1 0 0 1 equal to 100. Okay, now to improve our solution, what we need to do is we need to calculate the value of Cj minus Zj. We know that Cj is the objective function sorry, and Zj is the summation of xj into aij, that means 0 into minus 1 plus 0 into 0 plus 0 into 1. So this will be Zj. Now as we calculate, this will be equal to 0, so 12 minus 0 is 12. Similarly 15 minus 0 is 15, 14 minus 0 is 14. Now as s1, s2 and s3 are basic variables, they will attain a value 0 in Cj minus Zj row. So Cj minus Zj row, s1, s2 and s3 will attain 0 values, and the value of z, here we will calculate the value of z, our objective function. At this stage our objective function is 0. Now what we'll do is we will select the maximum positive value here. So 15 is maximum positive. This will be our key column. What key column suggests is which variable will enter the basis column. So by this we can understand that x2 will enter the basis column and replace s1 or s2 or s3. So let us see which one is the leaving variable, and to see the leaving variable we need to calculate another term which is called theta, and theta equals to right hand side value divided by corresponding key column element. Okay, now theta is, as in this case we can see that we are having two values as 0 in the right hand side. That means it is a possible case of degeneracy, and it will depend on the corresponding key column value. As we can see that 0 divided by 1 is 0, 0 divided by minus 1. As we can see here, this one is negative sign, and we have also discussed it in the previous lectures in the simplex algorithm, that if there is any negative value found in the key column, our ratio, that is theta, will come as negative, and we will not write it here, and instead we will put our dash sign only. This indicates that this is either negative or infinity, or if you want to mention, you can specifically in bracket mention negative. So similarly third, 100 divided by 1 is 100. Now as we can see here, which is the minimum positive value, so we will always consider 0 as the minimum positive. Okay, we will not consider it as negative or any other value. If I am talking about minimum positive value, 0 is always considered as minimum positive here. So we will select this as leaving variable, and this is called pivot row. So by now we understand that x1 will enter the basis and s1 x2 will enter the basis and x2 will replace s1. So let us write x2, s2 and s3. The coefficient of x2 is 15, s2 is 0, s3 is 0. Now in order to make this a unity matrix, what we'll do is we will select this pivot element, which is the intersection of key column and pivot row. Key column and pivot row, its intersection point is known as pivot element. Now what we need to do is we need to make this element as 1, as here it is already 1. We need to make this as 1 and the remaining values in the in this column as 0. So as it is already 1, I will be directly writing this equation. This will be minus 1, 1, 0, 1, 0, 0 and 0. Similarly, if this has to be 0, what I will do is row 2 plus row 1. So this will be 1 minus 1 will be 0. So I will write row 2 minus of new row 1. So this will be 0, minus of minus 1 is plus 1, 1 minus 1 is 0, 2 minus 0 is 2, 0 minus 1 is minus 1, 1 minus 0 is 1, 0 minus 0 is 0, 0 minus 0 is 0. Similarly, this has to be 0. So what we'll do is, what we have done here is we need to add this, okay, to make this 0, this plus this. So this plus this will be minus 1, okay, this plus this will be 0, this plus this is 2, this plus this is 1, not minus 1, this plus this is 1, plus this 0, this plus this 0, okay. Now to make this as 0, we need to subtract row 3 minus of new row 1. So 1 minus of minus 1 will be plus 1, so 1 plus 1 will be 2, this minus this, 1 minus 0 is 1, 1 minus 2 is minus 1, 1 minus 0, I should say 1 minus 1 is 0, 1 minus 0 is 1, 0 minus 1 is minus 1, 0 minus 0 is 0, 1 minus 0 is 1, 100 minus 0 is 100. Now again, to check the optimality here, we will again calculate the values of Cj minus Zj. As we can see that x2, s2 and s3 are basic variables. I'll write the values of x2, s2 and s3 as 0 in the Cj minus Zj row. Now to calculate this value, this will be minus 15, minus of minus 15 plus 15, this will be 27. Similarly, this will be 0, this is 14, this will come as minus 15, 0 minus 15 is minus 15, and this will come as 0. So now we can see here that initially we are having at least 1 0 as the right hand side value. That means the value of basic variable is 0 in the initial matrix, and as a result the value of z, that is the value of objective function, does not improve in the subsequent iterations, and this shows that the problem is degenerate. Now if we continue to solve the problem, we will see that the problem automatically comes out of degeneracy, as the simplex algorithm has been designed in such a manner. So let us solve further. Now again we can see that in the Cj minus Zj row, we will select the maximum positive value, which is 27, and this is our key column. That means variable x1 will now enter the basis, and to select the leaving variable we need to calculate the value of theta. Theta will be right hand side value divided by corresponding key column element. So 0 minus 1 here, that means we will not calculate it. Similarly 0 minus 1 here, we will not calculate it. Okay, 100 divided by 2 is 50. So as we can see here that the variable x2 and variable s2 are not eligible to participate, we will select the variable s3 as our leaving variable, and this will be our pivot row. This is very important to understand this, that the leaving variable does not only depend on the right hand side value, that is 0 or any other value, it depends on the ratio. And if the key column element, corresponding key column element is negative, we will not calculate the value of theta, or we will put a dash sign in the value of theta. This shows that the leaving variable it is showing is ineligible to participate for leaving the basis column. Now it is clear that variable x1 will enter the basis and it will replace variable s3. So now x2, s2 and x1. The coefficient of x2 is 15, this is 0, this is 12, and now we have this as our pivot element. Now we need to make this element as 1 and the remaining values as 0. To make this as 1, what I'll do is I will divide row 3 by 2. So I'll be getting 2 by 2 is 1, 0 by 2 is 0, 1 by 2 is 1 by 2, minus 1 by 2 is minus 1 by 2, 0 by 2 is 0, 1 by 2 is 1 by 2, and 100 by 2 is 50. Now to make this as 0, what I'll do is I'll take row 2 plus new row 3, that means 1 minus 1 will be 0. So row 2 plus new row 3. So this plus this is 0, this plus this is 0, this plus this 2.5, that means 5 by 2, this plus this is half, 1 by 2, this plus this is 1 by 2, and this plus this is half, okay, 1 by 2. Okay, now this plus this is 50, 0 plus 50 is 50. Similarly, here also what I'll do is row 1 plus new row 3. So 1 minus 1 will be 0. So this will be 0, this will be 1, this plus this is 1 by 2, this plus this is 1 by 2, 1 minus 1 by 2 is 1 by 2, this plus this is 0, this plus this is 0, okay, this plus this is 1 by 2, this plus this is 50. So now again what we need to do is there is some problem here, it will be 1, sorry, this will be 1, so that it will form unity matrix. Okay, then the rest is okay. Now we'll again calculate the value of Cj minus Zj to see if this is our optimal solution or not. So as we can see, the basic variables are x2, x1 and s2. So I'll putting the value of x1, x2 and s2 as 0 because they are basic variables. Now this will be 15 by 2, 27 by 2. Okay, this will be minus Cj minus Zj, this will be 1 by 2. Okay, and for this is 0 minus 15 minus 12, 3 by 2, that means minus 3 by 2. Similarly this one 0 minus 15 plus 27 minus 27 by 2, and the value of Z will come as 15 5175 1350 1350. Okay, so now we have seen that still one positive value is coming in Cj minus Zj row. That means our solution is not optimal yet, and we again need to select this as a key column, that means variable x3 now will enter the basis, and to decide the leaving variable we need to calculate the value of theta. So 50 into 1 by 2 is 50 into 2, that is 100. Similarly 50 divided by 5 by 2, that means 100 by 5, that means 20. This will be 15 divided by 1 by 2, that means 100. Now we can see that 20 is the minimum positive value here, so we will select the variable s2 as our leaving variable, and this will be our pivot row. Now it is clear that variable x3 will enter the basis and it will replace the variable s2. So I'll write here x2, x3 and x1. x2, x3 as x1 and x1. Variable coefficient are 15, 14 and 12. 15, 14 and 12. Now we will select the pivot element here. So the intersection of pivot row and key column is this. So this is our pivot element. We need to make this element as 1 and the remaining as 0. So I will be dividing row 2 by 5 by 2. So this will be 0, 0. 5 by 2 by 5 by 2 is 1. 1 by 2 by 1 by 2 divided by 5 by 2 is 1 by 5. 1 by 5. 1 divided by 5 by 2 is 2 by 5. 1 by 2 divided by 5 by 2 is 1 by 5. 50 divided by 5 by 2, that means 100 by 2, it is 20. Now I need to make these two variables as 0. So to do so, what I'll do is I'll take row 1 minus of new 1 by 2 times new row 2. So this will be half. 1 by 2 times of this will be giving 0. Okay, so this minus 1 by 2 times of this. So 0 minus 1 by 2 times of this, 1 minus 1 by 2 times of this, 1 by 2 minus 1 by 2 times of this, 1 by 2 minus 1 by 2, 1 by 2 minus 1 by 10. What it will give is 2 by 5. This will be 2 by 5. Similarly 0 minus 1 by 2 times, this will be minus 1 by 5. Okay, minus 1 by 5. 1 by 2 minus 1 by 2 times of 1 by 5. This will be given as 2 by 5. Similarly here also I'll do the same operation, that means row 3 minus of 1 by 2 times of row 2. So this will give me 1 minus this will be 1 minus of 1 by 2 times of this is 0. 0 minus 1 by 2 times of 0, 1 minus 1 by 2 times of 0 is 0. 1 by 2 minus 1 by 2 minus 1 by 10, this is I think 3 by 10, minus 3 by 10, minus 3 by 5. Here 0 minus, this will be minus 1 by 5, minus 1 by 5. Again this will be 2 by 5, 1 by 2 minus of 1 by 10, this will be 2 by 5, 2 by 5. Or here also I have to return 50 minus 1 by 2 times of this, that means 50 minus 10 is 40, and we are doing same operation here, so this will also be 40. So now this will our new matrix, and we need to calculate Cj minus Zj again to see if our solution is optimal or not. So this is Cj minus Zj. As x1, x2, x3 are basic variables, I'll be putting the value of 0 in Cj minus Z0. Now to calculate this is 15 into 2, 30, 44 minus 36 is minus plus 8 by 3, 0 minus 8 by 3 is, this is minus 8 by 5. Okay, this is minus 8 by 5. Okay, now this is minus 15, 27 plus 28, this will be minus 1 by 5. This will be minus 1 by 5. This will be 15 plus 24, 30 plus 24, 54 plus 14, 68. So this will be minus 68 by 5, and the value of Z is coming as, this is 60 plus 28, that is 88 plus 48, this is 136, so 1360. Now as we can see here that all the values of in the Cj minus Z0 is coming as 0 or negative. So this is our optimal solution, and we can see here the value of x1, x2 and x3 are coming as x1 equal to 40, x2 equal to 40 and x3 equal to 20, and it is giving the value of Z as 1360. So this is our final solution. X1 is equals to 40, x2 is equals to 40 and x3 is equals to 20. Z max is given as 1360. So this is our final solution, and what we have understood by this problem, that we need to see if there is a 0 value of the basic variable in the very first iteration, we can say that our problem is a degenerate problem. Okay, and we also need to see that even if this is 0 and there is a negative value in a key column, then we will not take this value or select this value as our eligible variable to leave the basis. So we can say that if we find any negative value, in the key column, we will simply not write anything on the ratio theta we are calculating. Clear? So if we find any negative value on the key column, we will not write anything, and this means that these two variables here are not eligible to participate for leaving variable. Okay, and more or less simplex is same throughout, and we need to remember this method for maximization only. Now as we have completed this problem, we have completed the degeneracy in simplex algorithm. In the coming lectures we are going to understand how to solve Big-M method and how the concept of artificial variable arises. We have not seen the artificial variable or discuss artificial variable till now. So to learn more about linear programming, Big-M method, artificial method, please stay connected with us. If you like the lecture, please share the lecture. Have a nice day. Thank you.